Hi, I'm Mike Schnecker from Rohde Schwarz. Today we're going to be showing a measurement of PDN crosstalk using our MXO 58 oscilloscope. So here we've got a demonstration board set up with two different power distribution networks. The first one is a 4-phase buck here, and there's a second converter right here, and they're both driving two different power domains on this one chip layout. And what we're trying to do is measure how a load step on one power rail can induce noise on an adjacent power rail. So we're probing the main power rail here. That's the yellow trace on the screen. And we're probing the victim power rail right here on the ball grid array, and that's the lower trace. And there's actually two traces shown here. One is white and one is orange. The orange trace is the active trace. Now, when we step the load on the primary power rail, it's going to induce noise onto the victim. But there's a situation where the two are switching asynchronously. So the switching noise, when the switching noise of the converters lines up with the step, you can have a higher noise induced into the victim. And we're capturing that using a feature of the MXO 58. We have a real-time zone trigger. So this, in addition to the step where we induce this load step, we're showing where the peak on the victim rail happens when the switching lines up with that step. And so you can see that we're measuring peak-to-peak voltage down here. Channel 1, 278 millivolts of noise induced onto the power rail when the load is removed. The white trace is sort of an asynchronous acquisition. It's when we don't have the zone trigger turned on. And we're actually just seeing the noise induced randomly onto the victim power rail, but you can see it's only 181 millivolts. However, when we find that worst case spot where the switching lines up with the load step, we're actually seeing a full almost 300 millivolts of noise induced onto the victim rail. And so using a real-time zone trigger, we can actually capture a worst case PDN crosstalk, which is a very important application for high-speed processors using AI and other applications where large currents are being drawn.